Okay. So, as x approaches 2 from the left, so here's 2. As I approach it from the left, so I'm on the left side of it, I'm getting closer and closer to this y, which is 2. That's right. Very good. All right. What about the next one, Daniel?
2.
It is also 2 because I'm approaching 2 from the right-hand side. So it's like I'm going down this line. I'm still getting closer and closer to the y value of 2. Now, what is actual f of 2?
There isn't one. There's a hole.
There is a hole, but what? Yeah, see, it's right here. F of 2 is actually 3.
-3.
Duh, -3. Thank you. That's okay. Does the limit... Oh, what's up?
It's not on the line, though.
That's okay. That's okay. This is a piecewise function. The whole thing is that line except for that point.
So there's a whole equation for that single point.
Yeah, well, it would just be a point.
But
It would say x equals, or y equals 2 when x is, no, y is -3 when x is 2. That's what it would say.
Why does the line not go through that point then?
Because it wouldn't be a straight line. It would be like, and you would be including points here that it's not actually including. Good question. So does the limit exist?
No.
Let's look at the rules.
Yes.
If the two left side, if the left side and the right side of the limit are equal, and they equal this number, some real number, then it exists. So does it exist?
Yes.
Yeah.
Yes. The limit as x approaches 2 of f of x equals 2. It does not matter that f of 2 is -3. Doesn't matter what f of 2 actually is. It's what is it getting closer and closer to. So it can either actually touch it or not. It doesn't matter. And that's where some people go, woo! All right. And now let's look, this is also a piecewise function. At example 3, oh, I was supposed to say why or why not. It's because limit as x approaches 2 from the left, and limit as x approaches 2 from the right are equal to each other. Again, see if you can fill in that one. I think they're working on the bulletin board. It's right there on that
Oh,
wall.
we're getting another one? Oh, wait.
No, there's one right there on the other side of that wall. So Faith, what do you think about the first one?
I said 3.
3? Okay, let's look at it. Okay, as x approaches 2 from the left. So as x approaches 2 from the left, yep.
See, it really doesn't look 3 right now, but I said 3 anyways, because it's like a little bit under it.
Oh, I think think it's supposed to be. It looks like it's straight across, but it may be a little under. I guess the middle of it's not quite. Okay, what about, let's see, Daniel, what about the next one?
-3.
Yeah, it's down here, so we'll change colors. Approach it from this side. It's down here, that's -3. What's f of 2?
3.
3. Yeah, it's right here, because it's a filled-in dot. So does the limit exist?
No.
No. Why not?
Because it's not equal.
Yep. Limit of f of x as x approaches 2 does not exist because the limit as x approaches 2 from the left is not equal to the limit as x approaches 2 from the right. Notice it had absolutely nothing to do with what f of x or f of 2 in this case actually equaled. It doesn't. Don't let that confuse you. All right. Moving on up. Okay. So based on what we've seen, does f of a have to be defined in order for the limit to exist? So, no. Like this one, f of 2 was not defined, but the limit didn't exist. This one, all of these. Yeah, but no, it does not. That goes back to what I was saying. It doesn't matter at all what f of a is. It doesn't have to be defined in order for the limit to exist. We're going to draw and explain 2 different graphs to justify our reasoning. In both graphs, f of a should be undefined, but in one graph, the limit should exist. On the second one, it should not exist. So, let me draw this. Okay, so basically, if a does not exist, I can have a hole in the graph. Whoa, I wanted it to be a curve. There's A. There's B. F of A is undefined. But the limit as x approaches A is what?
B.
B. I'll call that f of x. You may tell me what another one might look like. This time, with A being, let's see, the limit should exist, and then we're going to have another one where the limit doesn't exist.
So could they go opposite directions?
Yes. By that you mean like one pointing up and one pointing down?
Yeah.
Okay. So like kind of like if it had an asymptote. We'll call that A. This one, the limit, oh, actually, the limit does not exist in this one, my bad. Oh, yeah, it shouldn't exist. Okay. Limit as x approaches A of, I'll call this g of x, does not exist because one's infinity and the other one's negative infinity. Notice still, g of A does not exist either. just like on the other problem, f of a was undefined. It didn't exist.